The valve train includes all of the components that are driven from the camshaft to the top of the valves. There are different types of valve trains, depending on how many camshafts there are and where they are located. This is an overhead valve or pushrod system. The valves are in the cylinder head, but the camshaft is in the block near the crankshaft. A valve lifter or tappet rides on the cam. As the cam lobe reaches the lifter, it rises and transfers the motion to the pushrod. This then moves a rocker, which in turn pushes the valve open. There are different kinds of lifters. A solid lifter is usually a hollow cast iron cylinder mounted in a bore in the crankcase. It is free to rotate slowly, which distributes wear from the cam over the face of the lifter. The gap between the valve tip and the valve train is called valve clearance or valve lash. This must be maintained when the cam is not applying pressure to open the valve. It can be adjusted with a screw and lock nut built into the rocker arm. These adjustments are needed regularly. Many engines now use hydraulic valve lifters. Their purpose is to make the engine quieter and eliminate the need for valve clearance adjustment. When the engine is operating, oil under pressure from the engine's lubrication system is supplied to the lifter. The oil is assisted by spring tension to maintain zero valve clearance. But through a system of valves, it is trapped in the lifter as the camshaft lifts it. Since oil is not compressible, the lifter acts like a solid lifter. When the valve is closed, any oil lost during the previous lift is replaced, and zero valve clearance is maintained. Rocker arms transfer motion to the valves. The rocker arm rocks up and down using a pivot mechanism. Some rocker arms are made of cast steel or aluminum alloy. Others are a steel pressing. Hydraulic valve lifters usually use stamped or pressed sheet metal or cast aluminum rocker arms.